Imagine a force powerful enough to bury entire continents under layers of ash and disrupt global climate for decades. Supervolcanoes represent one of nature's most catastrophic phenomena. These colossal eruptions can release thousands of cubic kilometers of magma and ash, far exceeding the destructive power of any known volcano. Their potential impact on humanity is immense. Supervolcanoes have erupted multiple times throughout Earth's history, each time reshaping landscapes and altering ecosystems. They remain a hidden threat beneath our feet. Understanding these dormant giants is crucial. Scientists study them to predict future eruptions and assess their potential risks to human civilization. One of the world's largest supervolcanoes lies beneath Yellowstone National Park. Its last eruption occurred about 640,000 years ago, but it remains active. If Yellowstone were to erupt again, it could spew vast amounts of ash into the atmosphere, blocking sunlight and causing global cooling and crop failures. Despite the potential dangers, supervolcanoes also play a vital role in Earth's geological cycle, shaping continents and creating fertile soil. Scientists monitor seismic activity and ground deformation to detect signs of an impending eruption. Early warning systems can save lives if an eruption occurs. While the odds of a supervolcano eruption are low, their potential impact is so severe that understanding and preparing for such events is critical for global safety. Supervolcanoes like Yellowstone could release thousands of cubic kilometers of ash into the atmosphere, blocking sunlight and causing global temperatures to plummet. An eruption would trigger tsunamis, earthquakes, and disrupt air travel for years. The economic fallout would be catastrophic, affecting billions worldwide. Yellowstone's last major eruption was 640,000 years ago. Scientists study past eruptions to predict future activity, but accurate forecasting remains challenging. Tectonic plate movements create conditions for supervolcanoes. Magma pools beneath the Earth's crust, building pressure until it forces its way out. Scientists use satellites to track changes in ground elevation, indicative of magma accumulation beneath supervolcanoes, alerting us to potential risks. Seismic sensors detect tremors caused by magma movement. These signals help scientists monitor the volcano's activity and prepare for potential eruptions. Volcanic gases escaping from vents provide clues about the composition and state of the magma below. Changes can signal an impending eruption. Underwater volcanoes pose a hidden threat as they can erupt without warning and generate tsunamis, impacting coastal regions far away. Lake Tuba in Indonesia erupted around 74,000 years ago, potentially triggering a volcanic winter and causing a population bottleneck in early humans. The Lacher Sea eruption in Germany 13,000 years ago covered much of Europe with ash, illustrating how even distant eruptions can have widespread impacts. In Iceland, the Hekla volcano has been dubbed the gateway to hell due to its frequent and explosive eruptions throughout history. Mount Tambora's eruption in 1815 was one of the largest ever recorded, causing the year without a summer and leading to widespread famine. The eruption of Mount Pinatubo in 1991 released so much sulfur dioxide that it cooled the Earth's surface temperature for several years. The Taupo volcano in New Zealand erupted about 26,500 years ago, producing the largest volcanic eruption of the Holocene epoch. In the Philippines, the Mayon volcano is known for its near-perfect cone shape and frequent eruptions, posing ongoing risks to nearby communities. The eruption of Krakatoa in 1883 created shockwaves, heard up to 4,800 kilometers away, and caused massive tsunamis that devastated coastlines. In Hawaii, Kilauea volcano has been continuously active since 1983, reshaping landscapes and providing insights into volcanic processes. The Deccan traps in India were formed by massive volcanic eruptions about 65 million years ago, contributing to the extinction of dinosaurs. The Columbia River Basalt Group in North America covers an area larger than the state of Washington, formed during intense volcanic activity millions of years ago. The Siberian Traps, a large igneous province in Russia, were created by massive eruptions 250 million years ago, leading to a mass extinction event. Volcanic ash can clog jet engines, grounding flights, and disrupting global transportation networks, highlighting the far-reaching effects of volcanic eruptions. Volcanic eruptions can affect climate by releasing gases into the stratosphere, leading to prolonged cooling periods and altering weather patterns. While supervolcanoes are rare, their potential to cause global devastation means continuous monitoring and research are crucial for understanding and preparing for such events. Despite the risks, volcanoes also contribute to soil fertility and create new land, showcasing the complex relationship between these geological phenomena and life on Earth. One of the most notorious supervolcanoes is Yellowstone. Its caldera spans over 3,470 square miles, capable of ejecting thousands of cubic kilometers of ash into the atmosphere, causing a volcanic winter. The eruption of a supervolcano could lead to global famine due to the blocking of sunlight by ash clouds. This would impact food production worldwide, threatening billions of lives. Despite the catastrophic potential, there are currently no methods to prevent a supervolcano eruption. Monitoring systems can provide early warnings, but the scale of such an event remains uncontrollable. However, the threat posed by supervolcanoes is part of Earth's natural cycle. They have shaped our planet's landscape and climate over millions of years, playing a crucial role in its evolution. Supervolcanoes represent a profound natural threat, but humans have survived countless disasters throughout history. By understanding these forces, we can better prepare for the future. While we cannot predict when a supervolcano will erupt, scientific research offers hope. Continuous monitoring and advanced technology help us detect early warning signs. Understanding supervolcanoes' impact on climate and ecosystems is crucial. This knowledge aids in developing strategies to mitigate the effects of future eruptions. Investing in renewable energy sources reduces our reliance on fossil fuels, potentially decreasing the frequency of minor volcanic eruptions triggered by human activity. Educating the public about natural disasters increases preparedness. Awareness campaigns inform people on how to act during emergencies, saving lives. International cooperation is vital. Sharing data and resources allows countries to work together effectively, enhancing global readiness for a supervolcanic eruption. In the face of such monumental threats, humanity must unite. By pooling our knowledge and resources, we can safeguard our civilization from nature's fury. As we continue to explore and understand our planet, we uncover new ways to protect ourselves. Every discovery brings us closer to mastering our environment. The power of volcanoes may be immense, but human resilience and ingenuity are greater still. With each passing year, we become more capable of facing any challenge. In the end, it is not just about surviving, it is about thriving despite the odds. Supervolcanoes remind us of our vulnerability, yet inspire us to strive for a safer world. Let us embrace the challenge and continue our journey towards a future where we coexist with the Earth's natural forces, ready to face whatever comes our way.